Computer Science 190 lecture number 3, August 25th, 2020. Let's go. Okay, so overview of computers. First off, class updates. Yeah, so we're gonna have a quiz on Thursday. It's going to be online. It's going to be on Blackboard. Okay, you can take it at any time of that day. I don't know, from the moment when I publish it, which will be most likely something like 9 a.m. up until midnight. Okay, so within the time frame, at any moment you can basically go to the Blackboard and take that quiz. It'll be a mixture of multiple choice, fill in the blank, open-ended questions, essay questions. Yeah, everything is open, but you need to use your individual work, right? So you can't really talk to your classmates, but you can use internet, notes, book, whatever you want. Okay, you'll be timed. You will only have 15 minutes. Everything which was mentioned in class may appear in the quiz. So everything which I mentioned verbally, everything which I wrote in the slides, can appear there. So that quiz is going to contain the material from today's lecture and last time's lecture, which is Thursday, right? Again, you have the notes, you have these video lectures on this YouTube channel. Definitely, you can use them while you're taking that quiz. However, I found that again, since it's online, so normally these quizzes are everything closed, normally, okay? And since we do it online, since we doing that everything open, the questions will be a bit more complicated. And I definitely do not recommend you thinking that like you would see a question and then you will try to Google that, or you would go to online, you go to this video lecture and you look up the answer. You definitely need to know the answer, or at least be very close to that when you approach the quiz, when you take the quiz. Okay, because again, it will take only 15 minutes. Everything which was mentioned in the class may appear in the quiz. Okay, notes. I want you to take notes while watching this video and submit them by midnight of today, right? Class updates. So we're gonna have a lab on Friday. The way it's gonna happen is already, I think, talked about that, but let's repeat. It's going to be happening online via Zoom. You need to have this session ID and password. Okay, so on a designated time, you're going to log into Zoom, right? And you're going to have a tutor. He's going to introduce himself, and then he's going to present you a problem, right? For this week's lab, it will be very easy problem. He's going to talk about how to solve it approximately without giving you any specific details. And after that, you'll be broken into breakout rooms. 2 people or 3 people per room, and you guys will be kind of collectively trying to solve the problem, and tutor will be jumping between the rooms and he will be helping you answering your questions. Hope it makes sense. Yeah, so once you finish, show your work to the tutor, to the TA, right? So raise the hand in the Zoom, there's a raising hand option. Show him the work, share the screen. He's gonna tell you if it's right or wrong. Once he accepts your work, you can leave. So technically, I think the lab is 3 hours, right, or 4 hours. The majority of the people finish a lot earlier. I would say within an hour and a half or 2 hours. Really depends on the problem. Once your work is accepted, you can leave. Questions and problems are welcomed. So, for example, if you have any issues with the homework, if you have any issues with Eclipse, right, today we'll be talking about that, you're more than welcome to ask tutor about that as well. What else? Eclipse and Java on your computer. So you'll definitely need it for the lab, right? So by Friday, if you already installed Eclipse and Java and everything works perfectly, that's cool, perfect. If you still have issues, please schedule an appointment with the tutor. I have the link over here. Send me questions if you have them. If you have specific questions, send them to me. Worst case scenario, please use the online compiler, this one over here, and let's briefly talk about how to use them. Okay, so for example, I really like this online compiler. Well, I guess let's first walk through Eclipse. Eclipse. It's starting up. Okay, so when you just run it for the first time, you're going to see this, right? Basically selecting the workspace directory, You don't have to change anything. I wouldn't, so just click launch. By the way, one of the questions I received was from a student, are Eclipse and Java two different things? That is true. Eclipse and Java are two different things. If you have a Mac or you have a Windows, you have to install them separately. You install, for example, Eclipse first and then Java second. And if you do it on your Mac, then they automatically connect to each other. You don't really have to do anything else. If you do it on the Windows, then you have to install both of them first, and then you need to update the environmental variables. So what I'm going to do, actually, I recently built a new PC, and I think I'll record the screen of me installing Eclipse and Java there. So maybe, and I'll publish that, maybe it will help you guys as well. Okay, so now I'm going to show you what you need to do with Eclipse every time when you are trying to solve a new homework, solve a new problem, when you're trying to do, I guess, anything this class related in Eclipse. Okay, so I'm going to provide you the specific sequence of steps. I want you to repeat them as many times as you can, and that needs to become your muscle memory. Okay, there are like, I don't know, like 15 buttons which you need to push, and I want you to memorize them super well, and the whole lab number 1 will actually be dedicated to that. You need to memorize what buttons you need to push specifically for Eclipse in order to get the project working. Okay, so imagine I opened up my Eclipse, right? Don't really care about the color, it's not really important. Let's say that this project was not there, I'm going to delete it. Delete. Okay. So it's completely clean, Eclipse, right? So the first thing we need to do, no matter if you're using Windows or Mac, you need to go to File, okay, New. Then if you have an option of Java project, that's perfect, click that. If you don't have it, click on project. I'm gonna click on project. So here, what you need to do, you need to select, like, basically it's asking you what kind of project do you want to create. The idea is that Eclipse is a very powerful software, and it's built not only for Java projects, but for a huge amount of different languages. Well, this one specifically is for Java, but there are like so many options which you can choose from in this class, and probably for the rest of your school career if you're a computer science major. Here's what you need to choose. So again, File, New project, right? Then go to either click here, Java project, or go to Java and click on Java project. Then Next. Here you need to provide the project name. Okay, so that project name needs to be ideally one word, or like if you have a couple of words, you just concatenate them, like put them next to each other. Avoid spacing. So for example, and you need to start with a capital letter. For example, my, I don't know, first Java project, something like this. Okay. Then you can click next, or you can click finish. Let's click on next. Yeah, okay, I'll click finish. Perfect. Now, discourage module name. By convention, module names start with the lowercase letter. Okay, cool. So, module info.java. Just don't do anything here. Honestly, it's not really needed. Okay. So, in previous versions of Eclipse, actually, Eclipse didn't used to do that. That's really weird. So what I would do, honestly, I would just completely delete it. Module 4. I don't think it's needed. Default package. Okay, yeah, let's keep it here. Now, yeah, after that, what you need to do right click on source. You see that this like folder, src, source, right click on it, new, and then click on class. I know it doesn't make any sense, that's why you don't have to think about that, just do what I'm showing you and memorize that. That's it. Class. So in the class, again, provide the name, completely up to you what name that would be. You can actually duplicate the name from the project. So you can say my first Java and then class, for example. Next, what's very important, you need to mark this checkbox. Public static void main. Okay, again, don't think about that, and just mark it. Type already exists. Let's do project. Okay, perfect. My first Java project, and then click finish. Boom. Awesome. Okay. Class. What is that? Class project. Okay, I don't need that. I don't need this guy. It created two classes for some reason. Okay, cool. Yeah, perfect. And now, what I need to do, I need to kind of type some code over here. Let's say, like, hello, computer science 190 students. Okay, so the idea is that in this window over here, I'm typing all my code, right? And then once I'm ready, I can click the run button, which is going to execute this code. The run button is this green triangle. When I click on it, here I click OK. And then over here in the console, you see the console tab, you will see the output of that code, the output, the result of executing this code. Okay, so again, one more time. Let's do it very quickly. I'm going to delete this project again, and we're going to repeat the process. File, new, project, okay, Java project. Let's say like 3, lecture number 3, okay, finish. 3, don't create, module name, okay. Right click on source, new, class. Main, something like anything, mark this checkbox, click finish. Okay, and over here, just type like system.out.println and then hello. Done that, and now click on this triangle, like a play button, hello. Okay, and now see the console. So that thing, file, new, create, like new project, yes, file, new project. Type the name, then right click on source, new, class, mark the checkbox. So that's kind of what you definitely need to memorize. Okay, so one more thing. All the code you write in Java or in Eclipse or online compiler, that all code needs to go between the two braces. This brace over here and this brace over there. So over here between these two braces, that's where all of your code goes into. Okay, so if you write, and it's very important, and we'll be talking about it a bit later why, but as of now, again, there are so many like details which are connected to each other, and I do not want you to be overwhelmed already. So that's why I want you to know that if you, for example, if you have this line system.out.println, which basically means print out what I have between the parentheses. So for example, if I paste it over here, that's not going to work. It already kind of shows me, see this red cross? So if I click run, proceed, nothing. You see like exception, thread, compilation problem, error, okay? So you definitely need to remember that all the code you write, again, goes between this brace and this brace. If it happens that you forgot to mark the checkbox, which I told you about, what's going to happen is it's going to create a file, a class like this. You're not going to have the stuff I deleted, public static void main, right? You're not going to have that. And in that case, if you created a project, create a class, and it looks like this, then you need to type that out manually. You need to type out public static void main string, like these two brackets, args. Okay, you need to copy that like exactly as it is. Character to character, for example, this S is capital S. So definitely keep in mind, the capital S should be capital S. In coding, in computer science, it's very important. That's why I definitely mark the checkbox to make your life easier. So that's when we're talking about Eclipse. If we're talking about online compiler, let's talk about that. I'll come over here, online compiler. That's my favorite online compiler. When you're talking about online compiler, you don't have to create a project, you don't have to create a class. It's already there. It's much more simplified, but it's much more immature. All you have to do, you need to write the code over here. Again, between this brace and this brace, just write your code. Just say system.out.println hello. Okay. Once you're ready, click run. And then over here at the bottom, that's our console. We're going to see the output. And hello, perfect. Okay, hope it makes sense. Eclipse, right? Yeah, so worst case scenario, use online compiler. but definitely we need it. Please resolve all the issues you may have by Friday. Okay, so we are not getting into coding in Java yet. We need a few more things to talk about. Okay, so one of the simple questions I'll be asking: what does CPU stand for? What does it do? How many bits in a byte? What is the difference between high-level language and assembly language? Let's talk about Java first, how it was created. Simple history of Java. Okay, we'll be talking about like how it was created, application applet, first Java application program, writing, compile, and run in Java program. Applications versus app. Well, first off, let's talk about the history. Let's talk about the history. Let me delete this. Let me draw a couple of boxes. Okay, so first off, the first programming language which was developed, it was called A programming language. A. Okay, so we'll put A here. I forgot when it was developed. It was really back in the day, like in the 60s, 70s. Probably even earlier. I don't know. But anyway, so programming language was developed. It was back in the day when there were huge motherboards. There was nobody was gaming. Computers were really developed for geeks, for nerds, right? Like the general population would never think back then that computers would become such a widespread thing, and nobody thought about having iPhones or phones, anything like that. It was super long time ago. Anyway, so again, as I talked about last time, computer CPU only understands zeros and ones, nothing else, only zeros and ones, right? So each instruction would be, I don't know, 32. Really depends on architecture, but it would be, for example, 32 zeros and ones, each instruction. For example, if you want to add two numbers, it will be the instruction which would do that, which CPU would be able to understand, would be a series of digits, zeros and ones, 32 digits in that series, like 32 digit long, right? And of course, it's, well, for example, let me give an example like this, I don't know, 001, 110, even without the spaces. That's the problem, right? Then I don't know, it's not typing. Okay, 110, 0011, 1111. So that's already 1, 2, 3, 4, 5. So that's 20, right? And we need 12 more. Let's say 1010, 1010, 1010. Something like this. So this would be instruction of 32 zeros and ones, which would add two numbers, let's say, for example. It really depends on the processor, but let's say that's what it does. And of course, person who writes this code, the programmer, software developer, it was very difficult to understand that. It's very easy to make a mistake, because the problem is that, for example, over here you see we have 0001, right? But 0010, that would be, for example, a subtraction, or multiplication, or division. Super difficult to understand, unnecessarily complicated. And that's why people decided that, hey, let's try to write programming languages which will kind of look like English, right? And then they would be translated from, for example, like over here, system.out.println, which basically means print out the line, right? Print out the string, hello, which would translate like this into this, right? And the first attempt was the programming language called A. It was not popular, didn't take off, right? And that's why they created another programming language. And can you guess what it's called? It's called B, right? Super creative. And then they go to the same thing, didn't take off, not really popular. And then they came to programming language developed by Kiernan and Ritchie. It's called C. C programming language, and that thing like really took off, and it's still popular. A lot of people are still using that C programming language. That's considered to be one of the languages which will never die, which will never go away. C programming language, and then that C programming language, what they did, they kind of branched out into, can you guess, C+, right? And that branched out into C++, and then hold on. C++, and then of course became C#, developed by Microsoft, C#, Okay, yeah. So I think C was developed in originally 1963. I think C programming language. Wikipedia. Stable release. Hold on. Yeah. So Kernighan. Yeah. Richie Bell Labs. CH. When was it first developed? 1972. Okay, I thought 63. Okay, 1972. So 50 years ago, 48 years ago. That's how old it is, right? And then after that, yeah, but still, like if you guys ever coded in C, you notice that like it's kind of like also unnecessarily complicated. And then they, not like unnecessarily complicated, but it was very cool, like for that time, for 72, right? For 1972, but it had still some it still had some imperfections. And then one of the biggest problems, as I talked about that before, is that you need to write your own compiler, your own code for each processor, right? And that was very inconvenient. You have Intel, you have Qualcomm, you have I don't know, like IBM, well, Apple, right? Processors. For each one of them, you would have to write your own compiler, your own code. That's very inconvenient, and that's why they first, like I think in 1991, they created Java. Okay, so in the biggest advantage of Java was in the fact that you have Java virtual machine, and you can write your code on your computer, you compile that, and you can send it to somebody else, and he will still be able to run it. Although with C, what you would have to do, you would have to write the code, compile it, kind of make sure it works, and then send your friend the code, the source code. He will have to compile it on his machine and then to run it. And then, yeah, so that was very inconvenient. And Java, and there are like probably a dozen of other advantages, but that's the biggest one. Like the fact that it's compatible with any machine, any device, that definitely stood out. Yeah, so that's how Java was developed. It was, again, like it was almost 30 years ago, and C, C++, Java are considered to be languages which will never die, which never go away, which never fade away, because there are a huge amount of other languages which come and go, right? And only a few of them become like stay here for a while. One of other languages which is considered to be going that way is Python. Python as well is very, very, very popular, and most likely it's also not going to go away anywhere anytime soon. Okay, cool. Hope it makes sense. Moving on. Applications and applets. There are two kinds of Java applications, Java programs. One of them is called applications. The other one is called applets. Applications are regular programs. They're meant to be run on your computer. Applets, they're much smaller. They're meant to be sent to another location on the internet and run there. Some terminologies. The person who writes a program is called a programmer. So you would be a programmer for this class, or software developer, right? A person who interacts with the program is called a user. In our particular case, of course, that's going to be you. Like, so you guys will be both programmers and users. You'll be programming. You'll be solving the programming assignments, right? You'll be programming the code. You'll be writing the code, and you'll also be using that code, making sure it works correctly. In professional companies, in software development companies, there is a special position, and those guys are usually called QA, quality assurance, or testers, so software testers. What they do, they basically don't have that much knowledge about programming, but they know what a good program should look like, and that's why, for example, if a software developer writes the code, then he gives that to quality assurance engineer. That's what it's called, and that guy is going to test, is going to make sure that the program is usable from all different ways. And it's funny because the program basically kind of is all about finding holes, finding disadvantages, finding bugs in that code. For example, they'll be pushing, like, I don't know, one button 100,000 times, making sure that like it's not possible to break that application, right? If you push it, like, certain button like 100,000 times. Moving on, a package is a library of classes that have been defined already. For example, import java.util.scanner. Okay, so that's called a package. Again, those terms may not that might make much sense now, but then by the end of the course, it will definitely be much more clear. It will all make sense. Okay, moving on. The items inside parentheses are called arguments. So check this out. If I have a statement, so that's like one line is called a statement, one command is called a statement. If I have a statement and there are parentheses, and between the parentheses I'm typing something. So for example, what does this statement do? This statement basically says, hey Java, I want you to print out, so print line stands for print line. I want you to print out whatever is between the parentheses. So in this case, between the parentheses, I have a string with the text hello, right? If you say, for example, hello 1, then what will be printed out? Hello 1, right? Hello 1. Okay, so that stuff between the parentheses is called argument or arguments because there can be multiple arguments. A variable is something that can store data. Okay, so from maths you probably know like those, like you have x, y, right, as variables. So you can say, for example, x is equal to 5, right? Kind of similar how you do that in math. Okay, the only issue is that in Java in particular, first off, you need to add a semicolon. So every statement should end with semicolon. That's one. And number two, before doing this, you need to specify what type x is. So for example, in this particular case, x is what? Is a number, right? X is a number. And the most popular type of number is an integer. That's why over here, before saying x, you need to say int. That would basically mean that, hey Java, I want to create a variable called x of type integer, and the value of that x needs to be 5. Okay, and Java is going to create that variable x called 5. Yeah, sorry, with the value of 5. And then later, what you can do, you can basically print out x, right? So same thing, like you basically say in Java, hey, like I want you to print ln, print line, right? What do you want to print out? Whatever's between parentheses, and in this case it's x, right? So it's going to print out the value of x, which is 5, right? Okay, yeah, so it still prints out hello 1, right? Then it creates x, doesn't do anything, doesn't print out, and then over here it prints that out. Okay, so for example, if I delete this line, if I delete it, what do you think is going to happen? It's going to print out hello, then it's going to create x, but I never asked it to print out x, right? That's why x will never be printed out, and the result will be, it'll be the following. Just hello 1, right? Yeah, just hello 1, without printing out 5. Cool. Hope it makes sense. Yeah, anyway, so that's called a variable. An instruction to the computer is called a statement. It always ends with a semicolon. It's a very, very important thing. Like everything which you write over here, that has to be ended with a semicolon. And apart from some exceptions, which we will not be talking about anytime soon, yeah, so don't forget about semicolon. So for example, if let's say I delete this, and let's say I forgot the semicolon, right? I know it doesn't make any sense, like, why would you do that? But that's how Java was created, and I think they actually took it from C. It's a very important message to the compiler, basically saying, hey, I finished my line, and now I'm going to go to the next line. But of course, like to regular user observer, it wouldn't make any sense. Why would you finish up with semicolon? Anyway, so let's say I forgot the semicolon, and I'm going to push this button. What do I see? What do I see? I see error, right? Hello 1. Yikes. Okay, and now placing that back. Now it's gonna work. Perfect. Okay, moving on. The grammar rules for programming language is called syntax of the language. Okay, so grammar rules. You know, it's kind of like in English. I can't really, I mean, in English I can kind of omit some rules, I can kind of not follow them, and it would still make sense, right, to you if I, for example, I don't know, let me try to make a mistake like English. So I have I have been working on this homework, right? So that's this sentence should be grammatically correct as far as I understand. And let's say I make some grammatical mistake. Let's say I'll delete this, and I've been worked for homework this. Okay, so this sentence now contains multiple grammatical mistakes, but still, if I tell you I've been worked for homework this, you may probably understand what I'm talking about, right? Probably. Java is not like that at all. Java wants you to follow all the grammatical rules it has, and if you're not following a single tiny thing, it's going to throw you an error, like a single tiny thing. So for example, again, I already deleted a semicolon. You saw what it led to. Let's say now for example, I say, hey, I don't really like this dot, right? I'm going to delete the dot. Why would I need that? And let's try to run it. Do you think it's going to work? No, right? And the worst part though is this. You see, it says error cannot find symbol. Although we know that we made a mistake in terms of typing the dot here. But what does Java tell us? Cannot find symbol. So unfortunately, those descriptions, they are not really helpful at all. You can't really build them. Okay, so sometimes they help, sometimes they're not. 90% of the chance they will not help you. I mean, for programmers, for people who have huge amount of experience, so I understand what it means, right? I have no problem understanding how to fix it, but when you guys working on something, don't really rely on them. Okay. Similarly, for example, let's say why is system spelled with a capital letter? I don't think it's right, and now I'm gonna spell it with a lowercase. Okay, and now I'm gonna run it. Do you think it's gonna work? Of course, no, right? Same thing. What does it say? Package system does not exist, right? And that has nothing to do with the fact that we just need to type it with capital letter. Okay. Same thing over here. Let's say I want to spell public like this with a capital P, right? It's the first word of a sentence. That should probably be spelled with a capital letter. Let's see if that works. No, right? Again, what does it say? Class interface or num expected. Enum expected, right? Again, doesn't really help. How can we understand that we should just type it with the lowercase letter? But that's how it works. Moving on. Print to the screen. So whenever you want to print out to the screen, again, it's a magic line. You don't have to think about what it means and understand everything. Well, actually, if you guys are a computer science major, in next class in 226, either with me or some other professor, we'll be talking about why specifically we need to write it in that way. But anyway, so as of now, just remember this line: system spelled with a capital S dot out lowercase dot print ln, right, with these dots in between, and then a parenthesis, right, over here and over here, and then in quotes you need to just spell out some kind of sentence, whatever you want to print, and finish that up with a semicolon. Okay. System.out is an object for sending output to the screen. Println is a method to print whatever is in parentheses to the screen. Moving on. The object performs an action when you invoke or call one of its methods. Okay, so technically, over here, system.out is an object. So basically, kind of, I don't know. Think of a person, right? You basically say, hey, system.out, can you please print out this line, right? So this thing is called a method, and this thing is called an object, right? And this thing is called argument of that method. So you're basically asking this guy to do this, right? Print out on this. So you're basically saying, can you print out this statement? And you're giving him that statement. Okay, and that thing when you call a method is called invoke or call the method, right? So in general, basically you would say object name, right? In our case, it's system.out. System.out. And then you provide the method name, right? In our case, it's println. And then in parentheses, you provide the arguments, right? but kind of like additional information. So like basically saying, hey, can you please like print something out? And he's saying like, what do you want me to print out? Like, just give it to me, I'll print it out, no problem. And now here you're giving that to him. Moving on. Compile a Java program with a class. A Java program consists of one or more classes. In our case, in Computer Science 190, we'll be using only one class, but it's possible that you would have multiple classes. Usually what it looks like is that I would have multiple .java files like this. And of course, that's, I don't know, it's probably difficult to do it over here, right? But anyway, so Java program normally consists of one or more classes, right? But you definitely need to have one class, which must be compiled before running the program. You need not compile classes that accompany Java, system, or scanner, right? Each class should be in a separate file, right? So that's why you see, for example, it says class, public class. It basically means, hey, I want to create a class in this file. And it's like, you can't really do it one more time. You can't really create another public class in the same file. You're gonna have an error. Okay, the name of the file should be the same as the name of the class. Okay, so it's very important, especially if you're using Eclipse. So the name over here, main, right, should be exactly the same as the name over here, but with Java. So if over here I have the file is called main.java, that means the name of the class should be main. And spelled exactly the same way, so like with the capital K, like lowercase, capital case, so like it's case sensitive, and the letters should be exactly in the same sequence. Moving on. We use an IDE, Integrated Development Environment, which is basically this, right? Eclipse is one of the examples of IDE, Integrated Development Environment, which is basically like a software to make writing the code easier for you, which combines a text editor, right? So that's a text editor, right? I can write something here, with commands for compiling and running Java programs. So what you guys need to know is that, again, you create projects over here, you write the text, the code over here, and then you click the play button, and then it's going to execute the code. When a Java program is compiled, the bytecode version of the program has the same name, but the ending is changed from .java to .class, or not created at all. Okay, that is true. That happens when you use Eclipse. That happens seamlessly. You don't really notice that, but that's happening in the background. A Java program can involve any number of classes. Okay, so it's possible to have not like one file, main.java. It's possible to have like dozens of them. And usually, again, in professional software development, you would have, I don't know, hundreds of thousands of them. The class to run will contain the words public static void main. Yes, somewhere in the file. And that's super crucial, super important. And that's one of the things you should guys also memorize, and that should also become your muscle memory. So here's the thing. You can have huge amount of code in your file, right, in all different locations. However, somewhere in that code, there should be a method called main, and it should be there only once. So here's why. When Java is trying to understand how to run the code, it's going to evaluate, it's going to kind of read through the entire file, and it's going to look for only one thing only, which is the main method, which is this guy over here. And what Java is going to do, it's going to execute only, so one more time, it's going to execute only the stuff which is between this brace and this brace. It's not going to do anything else. Okay, so for example, if I have a couple of more lines like this, right, and let's say hello 2, 3, 4, 5, 6, what Java is going to do is going to execute this line, then it's going to go to the next one, this line, go to the next one, and so on. So it's going to execute the lines from top to bottom, but again, only between this brace and this brace. Nothing else. Moving on, errors. Okay, so what type of errors do we have? An error is basically anything in the program which kind of prevents it from working correctly. Error in the program is also called a bug. You probably heard that. Eliminating errors is called debugging, kind of removing those errors. There are three kinds of errors: syntax, runtime, and logic. Okay, so first one is syntax. Let's talk about that. Syntax is basically what you're gonna run into at first for like huge amount of times. It's basically like violating those grammatical rules, grammatical mistakes in a program. The compiler catches syntax errors and prints an error message, which is again almost useless. An example is using a period where a program expects a comma, right? So again, a program expects a comma, but you're using a period, or vice versa. Again, for example, if the expecting, let's say, does it work? I hope it does. Okay, it works. Perfect. Let's say over here we expect what? We expect a dot, right? But let's say we made a mistake, we forgot something, and we placed a comma here. And they kind of look the same, so you may not even notice that. And then we're gonna click run. Again, Java is super peculiar, is super like, I don't know, super strict about the rules. And that's why it's going to tell you error, not a statement, right? Again, what does that mean? And again, it kind of points to the system, although that's not where the error is. The error is over here. But at least it tells you what line it is at, because it's possible that you have like 100 lines of code, right? So let's say I have like this, and then boom, 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 boom. You see how many lines I have? Like 47 lines, right? And let's say I made a mistake somewhere, like again in this line, at least it's gonna tell you which line you made a mistake on. Moving on. So that's syntax mistake. Basically, if I get in a semicolon, typing in the colon instead of a comma, instead of a period, instead of a dot, exclamation point instead of something else, not writing stuff between these two braces, which I talked about, those are all syntax errors. Usually what happens is that people who take, like at the beginning of 190, you run into those errors a lot, but then you kind of get experience and slowly you eliminate all of them. Moving on, runtime errors. So what is that? Runtime errors are the errors where you basically wrote everything correctly, right? So Java can't really complain about the syntax, grammatically you did everything correctly, but then when Java attempts to run the program, there are some issues. For example, well, okay, so let's talk about this first. Errors are detected when your program is running, but not during compilation. Okay, so again, first off, your program is being compiled, that's one, then it's being run. Okay, so those errors were not detected during the compilation, they were detected only when the program was running. When the computer detects an error, it terminates the program and prints out an error message. Example, attempting to divide by 0. Okay, so let's talk about that. Let's say I'm going to create two variables. Okay, I'm going to create two variables. Let's say integer a, which is equal to 5, integer b, which is equal to 0. Okay, and let's say I want to print out the result of division a by b. Right, so division in Java is like that slash. Okay. Yeah, so do you think it's gonna work? Probably not, because I'm dividing by 0, right? But technically, again, I followed all the rules correctly, right? I have all the dots, all the periods, all the capital S, everything in place. So again, Java doesn't complain about the syntax, about grammar rules, but when it tries to run it, you see, tries to run it. But now it tells us exception in main thread, division by 0. Okay, so in this case, actually, the error description was useful. So those are called runtime errors. Moving on, logic errors. So logic errors are the errors that are not detected during the compilation, they are not detected during running, but cause the program to produce incorrect results. Okay, so again, you did everything correctly in terms of the syntax, you placed all of those dots, all the semicolons correctly. You did not divide by 0, so you divide by, I don't know, by something meaningful, by 1, right? However, the result, the program is not doing what it's supposed to be doing, what you wanted it to be doing. Okay, so for example, let's say attempt to calculate a Fahrenheit temperature from Celsius temperature, but multiplying by 9/5 and adding 23 instead of 32. Okay. So for example, again, if I want to create that temperature, right? If I want to convert, let's say Fahrenheit from Celsius, okay, so 30 for example, right? So 30 degrees Celsius, right, times 9/5, right? And then we need to, if we want to convert it from Celsius to Fahrenheit, right, we need to add 32. Okay, and in that case it's going to produce like more or less correct result. But if let's say we add 23, in that case it will be wrong, right? However, again, syntactically I did everything correctly. Everything was cool syntactically. Runtime, Java did not complain about this program. It's not going to complain about this program while running, right? There are also no issues with that. But the result, the output this program is going to produce, it's going to be different from what I want it to be, right? It's not going to do what it's supposed to do correctly, which is convert the temperature from Celsius to Fahrenheit. Cool? Perfect. Okay, awesome. That's it for today. Hope you guys enjoyed the class. Let me know if you have any questions. I'll see you on Thursday. Bye bye.